Hello, my name is Gustavo Vargas. I'm here with Malachi von Willey. We're going to talk about a gesture-based sign language translation. Part of the reason that we elected to do this project is because over 5% of the world population suffers from disabling hearing loss. This means that normal or verbal communication is difficult or impossible for them to use. In the United States, this translates to about 500,000 people who use American Sign Language as an alternative to verbal communication. And although American Sign Language is widely used and fairly well recognized, it is not understood by the average person. You can imagine how, for example, in an emergency situation, a person who uses American Sign Language would be unable to effectively or quickly communicate essential information to emergency personnel. We propose a solution to help in this communication barrier. Particularly, this solution will convert American Sign Language into either spoken language or, for our product demo, text. So the way that this works is the user would be able to use normal American Sign Language. This signals that are created by those gestures would be recorded by a signal acquisition system like the Myo-Band, which we'll discuss in a minute. Then through a process of signal conversion and processing, we'll be able to turn that into spoken language or, like I'd mentioned before, text. The way that this actually works is the Myo-Band is going to record the electromyographic readings, or EMG readings. Those are the electrical signals created when a muscle contracts or is activated. The Myo-Band will record these signals, and then using that data as well as gyroscope and accelerometer data that is embedded in the Myo-Band, we'll be able to map these different patterns to hand gestures and therefore signs. The Myo-Band is a device developed by Thalmic Labs. This device contains 8 EMG sensors. Those are electromyographic sensors that record the electrical stimulus produced by contracting muscles. It also contains an accelerometer and a gyroscope. This information is used to control various applications using gestures that are performed by the user. In order to actually translate the gestures that are recorded by the Myo into text-based sign language, we need to use a software development kit, or SDK, released by Thalmic Labs. At the core of this development kit is the libmyo library. This library allows us to call several functions that access all of the data being gathered by the Myo. In order to actually interface with this library, we need to use a series of language bindings. There's an official C++ language binding, but other language bindings can also be created. We use some of these custom language bindings in order to interact with other applications. In particular, the other applications that we're using are processing and a Myo Connect, which is software that's released by Thalmic Labs. Myo Connect recognizes Lua scripting. Lua scripting is Lua is a programming language that allows us to create simple scripts that we can actually use to interface with that libmyo library and access all of the necessary functions from the Myo. The actual gesture translation process utilizes the EMG readings gathered from the Myo's firmware and translated into a series of predefined gestures. In addition to these gestures, we also are able to integrate the Myo-Band's accelerometer and gyroscope readings in order to access the orientation and acceleration of the arm with the Myo-Band on it. Combining these data, we're able to translate gestures into actual sign language and again into text. Below you can see 3 examples of signs that we chose to translate for this product demo. On the far left, you can see the sign for drink, in the middle for table, and on the far right, the sign for mother. Malachi will now step through a simple product demo showing how each of these is translated.
The drink sign is performed by bringing a partially closed fist up to your mouth in a drinking motion. The sign for mom is performed by opening your palm and spreading your fingers while bringing your thumb up to your chin. To perform the sign for table, hold both your arms and forearms in front of your body and tap them together.
During this project, we learned several valuable lessons. First off, we learned that the technology required in order to actually translate sign language is fairly cutting edge, particularly for consumer electronics. In fact, the Myo-Band wasn't available until partway through this semester. In addition, we required a great number of muscle sensors able to detect the minute differences between one gesture and another. These gestures also vary between users due to several physiological factors. We need to be able to develop a system that's robust enough and flexible enough to handle all of these. This proved a difficult challenge. Furthermore, the scope of the problem is extremely large. We need to gather lots of data in order to properly implement each gesture and each sign. For the future, we hope to be able to use the Myo raw EMG readings. Right now, these readings are not released to developers, but starting in December of 2014, we will supposedly be able to access this data. Using this additional data, additional future work could consist of constructing a more robust application to counter the wide variability both in gestures between sessions and between individuals, and also to handle more signs. Particularly, the use of a secondary Myo-Band could be used in order to capture signs that require two hands. Thank you for listening to this presentation. Below you can see our contact info and references.